This meeting is being recorded.
Okay. So we want polished received pronunciation, please, Jason.
What was that?
Okay.
Oh, proceed. Yes.
We
yes.
want polished BBC English from you.
I will try my best. I will try my best.
Okay. Thank you. Well, perhaps I can introduce Jason, who is working with Bob McMurray and I on the cochlear implant project in Iowa, and Jason, as you'll find out shortly, has a very strong background in speech perception. And he's been working with a new battery that we've been developing to measure speech and noise perception in Iowa. I'm very grateful for you for talking to everyone today, Jason, as a sort of public service journal club, where you're going to be telling us not just about speech in noise perception, which is interesting in and of itself, but also about the mechanism that you've been using to actually do experiments online during these difficult times. So thank you so much. How much are you going to need for your presentation, Jason?
I have no idea. I was gonna do like a little talk, and then we would talk at the end. So maybe like, I don't know, 20 minutes, 30 minutes, something like that.
Okay. Well, let's go through. I guess if there are any sort of immediate technical questions, people can put their hand up. Given that it's a Zoom meeting with quite a few people joining, and I'll look out for that and pop you in. But otherwise, we'll have a sort of discussion afterwards and take more general and other questions in. Thanks, Jason.
That sounds good. Do you want me to get started now, or are there people that have questions?
Sounds like you can get going. Thanks.
Okay, awesome. Thank you. So first off, I just want to thank you for inviting me to Journal Club to talk about this timely issue. So today I'm going to be talking about online data collection. So what I want to do today is talk about some of my experiences with collecting data online, and hopefully I will be able to answer some of the questions that you may have about online data collection when I am finished today. So I want to preface this talk and say that I'm not an expert in online data collection, by no means. A few years ago, I got really interested in online data collection. And I think at that time I realized that online data collection was going to be, the future of doing science. So meta scientists talk about paradigm shifts and they talk about revolutions. And I really think that online data collection is going to be the predominant mode in which we do science. And I think we're already starting to see that now with this pandemic. So with having said that, let's get started. So it's been probably about a month now, but a month ago, it was business as usual in the labs. So we were running participants in our physical labs, and hopefully you weren't torturing them. So this is my psychology humor coming out. But instead, you were probably collecting data, eye tracking data. You were collecting EEG data. You were collecting fMRI data, MEG data, PET data, what have you. So life was good. We were getting data. And then disaster struck. COVID-19 essentially put a halt on all non-essential research. So that leaves us with two options. The first option is that we can stop collecting data. I'm sure all of us have papers that need to be written or data that need to be analyzed, but that's not fun. We are scientists. We want to collect data. We want to test hypotheses. We want to test theories. So the more favorable option is that we should be collecting data online. So instead of sitting idly by, probably about a month ago, I came to the group that I work with, and I recommended that we start collecting data online. We were in the midst of validating a measure that we've been working on called the Iowa Test of Consonant Confusion. Internally, we've called this ISNT, which is the Iowa Speech and Noise Task. And this task is a 4 alternative force choice single word speech and noise task. And essentially individuals just choose a response. So they choose the word they think they heard in the noise. And that's essentially the task. And for this validation study, we wanted to do it in 2 sessions, spaced 1 week apart, so 7 days. And we wanted to look at the psychometric properties of the Iowa test of consonant confusion, or ISNT. So we wanted to look at test, retest reliability. When individuals came into the lab, they would first do this ISNT task with 2 speakers, 1 male, 1 female, and then they would come back 7 days later, and then they would do the same task, but with 2 different speakers, 1 male, 1 female. So we wanted to look at test, retest reliability. We also wanted to look at convergent or divergent validity. So we wanted to correlate ISNT with, kind of the gold standard or classic measures such as CNC and AZ Bio. And unfortunately, I don't have any data to show you today. So I actually put this experiment up online last week on Prolific, and the data is, pouring in. We should have a finished project by this week or early next week. So I can't show you any data, but I will tell you a little bit about it and the process that went into it. So when I was creating this validation experiment to be put online, there was a lot of options to choose from. So Felix sent out that really, really nice table. So there's platforms like Open Sesame, PsychoPy, Qualtrics. The platform that I chose to use was Gorilla, and I'm really happy with the choice that I made. So Gorilla is kind of this all-in-one platform. So you're able to build experiments, you're able to host experiments and run them all from the Gorilla platform. So it's essentially an experiment, task, and questionnaire builder. And what I really like about this is that you don't have to go to different platforms to construct your experiment. So if you're using PsychoPy, for instance, you can create the task in PsychoPy, but if you wanted to also have some questionnaire measures, you would have to probably build something in Qualtrics and then link that through Pavlovia, which is not ideal. So Gorilla allows you to do all of those things all in one. So Gorilla is completely web-based, so everything is done in the browser. So you do not have to download any type of software. And it's a GUI. So individuals are able to kind of construct these experiments graphically, and no coding experience is necessary. But if you have some more complex designs, you can definitely code if you're proficient in JavaScript or some of the HTML languages. The actual experiment is hosted by Microsoft Azure. One kind of downside or one negative of Gorilla is that it's closed source, and you have to pay to collect data on Gorilla, so it's about $1.08, but it is free to build. So you can have collaborators look at your experiment to pilot it, but if you actually want to collect data, you actually have to pay. And I don't think it's prohibitively expensive. I think Pavlovia is about 20 cents, 30 cents per participant, so it's a little bit more expensive, but it's not too bad. So what I'd like to do now is walk you through the ISNT experiment on Gorilla. So let's see if I can get this started. So can everyone see the Gorilla webpage?
We're still looking at your last slide, Jason.
Okay, so I'm going to stop sharing and then I'm going to share again. There we go. Can you guys see the web browser now? Awesome.
Got it.
Yeah, so this is the Gorilla web browser. So this is the Gorilla page. So this is not going to be me explaining how you build a task. So if you're interested in knowing how to, or learning how to build a task, what you can do is you can go to the support page here and you can view some of these really great videos here. So if you view these videos, I guarantee that you'll be up and running with an experiment within the hour. It is very intuitive and very easy to create an experiment with Gorilla. So I'm not going to really talking about that, but instead I'm just going to be talking about kind of the layout of the ISNT experiment. So to access the ISNT experiment, you go to projects. So these are all the projects that I'm working on and also the projects I'm collaborating on. So we'll click on ISNT. So there's kind of 3 panels or 3 main sections of a project. There's the experiments. So these are all of your tasks and questionnaires connected together. There's tasks and questionnaires, which are kind of the individualized questionnaires and tasks that you build. And then there's open materials, which I think is great. Gorilla supports open science. So you can actually take any of these experiments that you create and you can essentially make it public or open to anyone who wants to look at the materials. So you can link these projects in your papers, and they can actually go to the actual website and they can view the project in real time or view the experiment in real time, which I think is great. So let's click on the isn't experiment or the isn't validation. So this might look intimidating, but it's just a lot of boxes and arrows connected together. And what I want to do is kind of walk everyone through kind of just the basic design of the experiment. So again, we have the start and finish node. So individuals start here and they end down here. And what individuals see first is a consent form. So individuals have to consent to be in your experiment. Pretty standard stuff. If individuals consent to your experiment, they go to the next branch. If they don't consent to your experiment, then they are rejected from the study. So if they consent to isn't, what they first go to is the headphone check. And I think that this is actually the most relevant to folks in this group. And I think it's one of the most important parts of any type of auditory experiment if you're going to do that online. And what the headphone check is essentially is kind of just, it provides an assurance that individuals are able to hear the stimuli that you're presenting, and they're able to listen to them at some type of reasonable volume. So let's take a look at what that looks like. So individuals will first be presented with these instructions here. So they have to adjust the volume. So by clicking on this play button here, they can adjust the volume to a reasonable level. So hopefully people can hear that. And then if you heard that, then you would adjust it to a reasonable level. What I think is really neat about this headphone check, so after this, there's this kind of really, I think, neat 6-trial type of little mini experiment. And in this experiment, individuals are presented with 3 tones of the same frequency, but one of them is lower amplitude. And individuals have to decide which one is the softest. And what I think is really neat about this is that if you are listening to the tones on headphones, you should have no issues with being successful at this task. However, if you're listening to this in free field, there's actually some issues and you won't do well. So then individuals would select which one is the softest. So I'm going to intentionally fail this. So in this experiment, I have individuals do this twice. If you're going to be doing auditory experiments, I recommend that you have something like this, and you have participants do it multiple times. Individuals really need to be paying attention and listening to being able to listen to the stimuli. So I recommend that you do it multiple times. The attrition rate or the individuals that get rejected is probably about 10 to 20%. So the more times you do this, the less data that you're going to have to throw out.
Jason, sorry to interrupt. This is directly relevant. Do you have a reference you can share with people about the validation of the headphone test?
Yes, I can definitely send that to folks. It's Woods et al. 2017, but I can actually send the reference.
Thank you.
Yep. So the headphone check is important. If they get 2 tries, they get 2 attempts. If they fail both attempts, then they are rejected from the study. But if they pass it, then they go to the second part of the experiment, which is a randomization node. And Gorilla is entirely spreadsheet based. So the flow of the experiment the flow of the actual task is dictated by the spreadsheet. So this randomizer node essentially, allocates people to a particular spreadsheet randomly. So they might go to, the Emma and Francis spreadsheet or the Desmond and Wendy spreadsheet. But what I would like to do now is kind of just show you the isn't experiment in real time. So individuals are presented with the instructions for the task. That's pretty standard. So in this this is a practice block that I have here. And what I have here is a progress bar. For online experiments, I definitely recommend that you have some type of progress bar, especially if you're going to have them do lots and lots of trials, because they're going to get fed up pretty quickly. But if the progress bar is there, then, you know, they might be motivated to finish the experiment if they know that they're, you know, very close to the end. But with this is a practice block, and what I've actually worked in here is, you know, just feedback. So it's we can't give them feedback in real time like we can in the lab. So on the online experiment, it's important that at least in the practice trials, you have some type of feedback. So you just click on it. That's wrong. That's wrong. Sure, they got that right. So yeah, so that's kind of just an example of what isn't looks like. This is just a practice block, but the second block and the third block are very similar. So we'll skip that. So after they do isn't, then they go to the CNC node. And CNC is very similar to isn't, but instead of actually selecting a response, they have to type in the response. So let's see what that looks like. Again, just the instructions for the task. I have no idea what that was. I think it was geese, and then they could type in the response. And what I think is really cool here, so individuals can type in the response if they want, or they can actually just record themselves saying what they thought they heard. I probably wouldn't recommend that unless you want to do lots of you know, processing on the back end. This one kind of just does a quick and dirty automatic, you know, accuracy check. So if they get it, if they spell it correctly, then it's, you know, marked correct. If they don't, it's marked incorrect. So it's kind of a very quick, simple way to get accuracy.
C.
I have no idea. C. Yeah, there you go.
Dead.
So yeah, so that's CNC. So as I told you before, this is a 2-session task. So they're spaced out 1 week apart. So what I've included in here is that kind of this delay node. And this delay node, so individuals go to this delay node and essentially they wait there for 7 days. And what Gorilla does is that they send them an email after the 7 days has passed. So they send them an email telling them that they can participate in the next part of the experiment, which I think is really cool. So that eliminates some of the RA or lab manager work, trying to track down participants to come back to your study. So after the 7 days have passed, they do the headphone check again, and then they do isn't again. And then they do AZ Bio. So we'll look at that.
We have heard his jokes 1,000 times.
This is a sentence-based speech and noise task, and then they would just, you know, type the sentence or the words that they thought they heard. So that's AZ Bio. And then after this, they would get demographic questionnaires, so just standard questions that we usually ask participants. What I've included here is, did you have any trouble hearing any of the audio presented, which is important, especially when you're analyzing the data. You probably maybe not want to include those folks that have issues with audio. And then also what I've included in here is just asking them what brand of headphones they're using to complete the task, just so we have a record of that. So this is the essential layout of the ISNT experiment. And the reason why I didn't really want to walk through how to build up a task is because everyone has different needs. But if you have any questions about this, again, you can refer to the really great videos that Gorilla has, or you can just reach out to me privately, and I'd be more than willing to help out. So this is kind of the basics. Yeah.
No, sorry, I don't want to interrupt your flow.
No.
I was just wondering whether, you know, when you have the multiple choice, so like you've got for isn't for that example.
Yeah.
How does it scale if they've got it windowed, for instance? Do they will they still see all the 4 options? Can you know if they've seen all the 4 options? Does that make sense?
Yeah. So I mean, that's a good question. I think that it does some automatic scaling to where like it fits whatever browser screen you're using.
Okay,
but I can't, I can't be too sure. So I do have preliminary evidence that individuals, at least in one version of isn't that we did online, are getting like, you know, 70, 80, 90%. So I would assume that they're actually able to see all the options.
Yeah, that's cool. Thank you.
Yeah. So I definitely think that there's some type of scaling that goes on.
Can I also ask a question, please? Sorry.
Yes.
This is Maria Chait from UCL.
Mhm.
Have you had a chance to explore reaction time, stability, measurability in Gorilla? Or maybe you know others who have?
So yeah, so you're ahead of me. So I'm actually going to talk about some frequently asked questions that individuals have about online data collection. And that's actually next. So I will be talking about that, and we could talk about that a little bit more.
Excellent, thank you.
Yes. So yeah, so that's really a nice little segue. So what I want to do now is transition to talking about some frequently asked questions or commonly asked questions that individuals have about online data collection. So what I did was try to come up with some answers to some of the common questions. But at the end, if there's any questions that I didn't answer, we could talk about those a little bit more in depth. So one of the questions that individuals have when they're doing online data collection is, how good are the data? So what's the data quality look like? So can you get effects that you get in the lab online? And I think that there's some good evidence to suggest that you can get good data. So Zwan et al. In 2008 did a MTurk study where they looked at some classic cognitive tasks. So the Simon task, Flanker task, spacing effect, false memories. And they had individuals come in, so they had individuals do these tasks multiple times, so 2 sessions. The first session they came in and they did one of these tasks. That's what the numbers on the graph represent here. So one would represent the Simon task. After they finished that, they would come back in at a second time, and they would either do the same task with the same materials, so kind of a very just an exact replication, or they would do the same task with different materials. And these are all the effect sizes from wave 1 and wave 2. And this is a really reassuring graph, at least to me. So anything on this dotted line represents equal effect sizes between the 2 sessions, but everything is really close to this line. So what we see here is that you can replicate these kind of classic findings in the laboratory, and that they're reliable. So you can get kind of similar effects across time.
These are all visual tasks, aren't they, Jason?
Yeah, they're all visual tasks. I do have an auditory type task.
Oh, right.
So last summer I did an experiment where I collected data on MTurk, and I was really interested in desirable difficulty. So these are any type of techniques that serve to make learning initially hard, but have the long-term benefits of making learning more durable. One type of technique is the generation effect. So when you generate a stimulus compared to just reading that stimulus, you have better memory for it. And we were able to replicate that. So this is a nice generation effect here. So individuals that had to generate train instead of read it, you get better memory for that. And what people are really interested in here are some auditory evidence. So Slotz and Strand in 2016 did a study where they compared lab data versus Amazon MTurk data. And they did 2 experiments. One, and this, what I'm showing here is just speech and noise accuracy. They also did an auditory lexical decision task too. But what we can see here is that in the lab, accuracy is a little higher than on Amazon MTurk. But when we look at the scatter plot here, we see that there's a nice positive correlation here. So we see here that there's a nice relationship between lab-based studies and also online-based studies. So you can replicate things that you do in the lab online. So it's been recommended that if you want good quality data, you should keep your experiments brief, fun, and the instructions easy to understand. A lot of people that are online are not, undergrad students. They've never been exposed to any of this stuff before. So it's really important that you make things clear for them. So probably one of the most frequently asked questions is, how good is the timing? So me as a cognitive scientist, I want to present stimuli and I want to record, responses at millisecond or sub-millisecond precision. So what does the actual data look like for this? And all I can really say is that timing is reasonable. It's not the greatest, but it's not bad either. So Anwar and Irvin, who works for Gorilla, they published a preprint a couple months ago. And this preprint looked at RT delay, so how long after a button request does it register, and also visual delay, so presenting stimuli for different durations. And they looked at different operating systems and different browsers and also different platforms, so Gorilla, Psycho.js, etc. And in terms of reaction time delay, we see for Gorilla at least the RT delay is about 80 milliseconds, which is honestly not the greatest, but it's not too bad. And there was another group that released a preprint a couple months ago as well. I think Jonathan Pierce's group, and there were some others on there as well. They have a little bit more favorable results as it relates to RT. But yeah, so we can see here that it's probably around 60 to 80 millisecond delay when you're trying to record reaction time. So not the greatest, but not too bad. And this is consistent across operating systems. So this is Windows, and then this is Mac. Again, you get that 60 to 80 millisecond kind of delay. As it relates to visual delay, it's a little bit better. So with Gorilla, it's about, with the standard error confidence intervals, so maybe like 10 to 40 milliseconds, around 10 milliseconds for some. So that's not too bad if you're presenting things for, in this particular experiment, they presented things for, I think, 100 milliseconds, 200 milliseconds, 300 milliseconds. There's been some studies that have looked at kind of mass priming, which is something that I'm interested in and research that I've done, where you present things for like 60 milliseconds, 50 milliseconds. Those type of studies, the evidence is a little bit mixed as to, if you can, accurately present something for that short of duration. But they have done some things with like 50 milliseconds, and they've shown, they've been able to replicate some results. And so I don't have it here, but the other paper I was telling you about, the mega timing study with Jonathan Pierce, they actually looked at auditory presentation. They didn't look at solely auditory presentation, and instead they looked at the coupling of auditory and visual presentation. And the results are not that great. So they're looking at, delays or lags of about 200 milliseconds when you're trying to present auditory information with visual information. So my recommendation, if you're not going to do like a solely auditory experiment where you're just playing audio, but instead you're trying to couple auditory stimuli with some type of visual stimulus, I probably wouldn't do that online. It seems that it's too variable and the delay is too long. 200 milliseconds is quite a long time, especially when you want a tight coupling between the two. So yeah, so some initial evidence, or this is some RT data, or timing data. Again, I think that it's reasonable. It's not the greatest, it's not the best. For the things that I'm doing online, I think that it's not that big of an issue, but it might be an issue to some other folks. And then if anyone is interested, the mega timing study has a table, a nice interactive table showing some of the RT variability as relates to like visual and RT and the auditory presentation times. One of the last questions I want to talk about before I kind of open it up to other questions is, are there limitations to online data collection? And the answer is simply yes. We can't collect data on everything that we want to online. So we can't collect eye data, although there are people who are working on developing that. We can't, do EEG, we can't do fMRI, we can't do those things. So there's definitely some fundamental limitations about the things that we can and cannot collect online. So there are definitely some limitations to online data collection. So now what I would like to do is open it up to other folks that have questions that have been kind of burning a hole in them since this whole pandemic started. So I'd like to open it up to questions if folks have them.
Thank you very much indeed, Jason. That's very helpful and very clear, and I guess it's kind of partly reassuring, at least with respect to performance, if not timing measures. But we can get something for that with pure auditory timing measures. Just a couple of very general points. First of all, can you say anything about the sort of research governance here? Do you have ethics for the study? I can't remember. And my other question relates to the what we call GDPR here, so the security of personal data and the security of the data on the server.
So all experiments here at least go through the IRB, the ethics committee. So you would, with a regular in-person study, you would go through the same procedure. So yeah, there's definitely a code of ethics that are associated with online data collection. As it relates to just storage of data, whatever Microsoft Azure does, I mean, I think that that's pretty secure. So, it's not your own personal server that you're storing this data on. You're storing it on Microsoft Azure, which has their own encryption and security measures. So I think that you can be assured that the data are going to be safe for the most part.
Sorry, go on, Maria.
Sorry, I'm just going to add to that because we were investigating in the context of GDPR because Gorilla is in the EU. That is good for GDPR, like for UK EU specific GDPR concerns. It's also the case that because you're recruiting participants through, I guess, Prolific or some other
Prolific MTurk,
where you are offloading. So as an experimenter, you can choose to limit the kind of identifiable information you would have about participants. So you would not have their name or address or any of that stuff. And hence, you're also in that sense safe for GDPR. And in terms of ethics, kind of broadly, at least UCL, but I'm guessing the same would be true for Newcastle, has been streamlining the conversion of ethics from lab-based to online-based research. And at least in UCL, they have this category of experiments that where you basically take the same general paradigm and just move it online. Are promised to be approved kind of super quickly. So we need the equivalent of an amendment, even like simpler than an amendment.
Thanks, Maria. That's very helpful. And we've done it before at UCL, with the figuregram task we put onto a mobile app. Sorry, Jason, you were saying?
Oh no, that's exactly what the process here as well. In terms of just a simple amendment, but I mean, there's still like a code of ethics that have to be followed when you're doing online data collection for sure.
Any other questions? I'm just looking at that.
Quick one, very different. Hi, this is Manon.
Hello.
Hi, Manon.
Manon Gruber. Hi, currently stuck in Leipzig. I just had a quick question. The paper that you mentioned, unfortunately, my connection went really bad and I missed out on the details. The auditory paper that you mentioned, can you give any pointer to that? I just missed the details.
Yeah. Are you talking about the Slot and Julia Strand paper, 2016? This one?
No, it was one that you only mentioned later on. It wasn't on the slide.
So are you talking about the headphone check one, the Woods et al. 2017?
No, it was when you were talking about timing issues, and as far as I could make out from the audio, it was
so it's called the Mega Timing Study. So if you type the Mega Timing Study in, it should direct you to a PsycArXiv preprint with Jonathan Pierce.
That was okay.
Yeah. So in that particular study, they didn't look at auditory stimuli, solely. They looked at the kind of fusion of auditory and visual presentation together.
Okay, thank you.
Mm-hmm.
Any other questions?
Hi, Jason. It's Gordon at UCL. Thanks for the presentation. It's very interesting. So just a quick question regarding, did you run into any technical limitations of the Gorilla platform when you were designing your experiment? And did you resort to writing JavaScript at any point, or were you able to describe it completely in the GUI?
So I was actually able to develop all of this complete with just the GUI. So what I'm doing is not very complicated at all. So one of the questions that I'm getting a lot now from auditory folks is, can you do adaptive type procedures online with Gorilla or CyclePy? And unfortunately, I think that the answer to that right now is no, you can't do any type of adaptive procedures. But I mean, maybe if you're really good with coding, you might be able to create something like that. But I'm not aware of anything that's available right now in terms of adaptive type of processing. Unfortunately.
Yes, sorry. I'm Sujia from Maria's lab, also from Fred Dick's lab from Burbank. I actually also work on that. I just figured out how to do it. And it's true. It's just adaptive staircase that you just. So I have the code to do that in Pavlovia now.
Oh, really? Okay, so via CyclePy, right?
No, it's a pure JavaScript one.
Oh,
Because
okay.
CyclePy doesn't do it. You have to write it by yourself. But I think
yeah. So,
it's durable and it's readable. Yeah, you can contact me if you want to do that.
awesome.
It's
awesome.
quite painful. It's quite painful.
Yeah,
but
no. I figured it would be quite painful.
yeah, it's definitely very painful.
Yeah, and unfortunately, I think a lot of people now that want to do online experiments are not really familiar with coding, unfortunately, or JavaScript, and they just want to do something very quickly. So something they just want to, they want to string something together and put it online.
Definitely, it took me 2 weeks to figure out.
Yeah. So it's definitely not trivial.
Okay, thanks, Jason. So, but it is possible to integrate your own JavaScript code into the query should you need to. Okay, cool. Thanks.
Any other questions? Okay. In that case, we can finish early. Thank you so much, Jason. That is extremely helpful, and I guess people who know who you are now, if they have further questions, I don't think you'll be inundated. And so we can finish the Journal Club there. Felix, you were there. Oh.
I am. Hi.
Hi. I think so. Actually, Maria might be interested in this. We're talking about attentional blindness in simultaneous translators next week, I think, aren't we, Felix?
Yes, that's correct.
Yeah. So you'd be welcome to come back.
I have it in my calendar.
Yeah, you'll be welcome to come back and join us for that as well. Felix,
Excellent.
any other announcements for today about the journal clubs or anything that's coming up?
Nope, not really.
Okay, great. Felix, you and I and Chris and others will catch up for the primate meeting at 2 o'clock. Shall we do it on this channel?
Yeah, that's fine with me. Can do that.
Okay, that's fine. So we'll hook up in 20 minutes on this channel. Goodbye, everyone. Thanks for joining, and particular thanks to Jason. Goodbye.
Tim?
Yeah.
Oh, hi.
Hi.